So, welcome to openEHR in Practice webinar. We have over 200 registrations, so I think it is really amazing. And this webinar is hosted by openEHR International's Education Program Board. And you can see all these happy faces here. So Heather, myself, Hanna Pohjonen, Jan, Gustav, Louise, David, and Jonathan. And our mission is to take openEHR knowledge to the masses. And today there is a special focus on secondary use of data and how open standards work together. Okay, and the next slide. And open standards really do work together. And they have different purposes, they have different strengths. To simplify, I think that we could say that we can prioritize FHIR if we are focused on data exchange. We can prioritize on openEHR if we are focused on data persistence and meaning. And finally, we can prioritize OMOP CDM if we are focused on data analysis. We have a very interesting agenda, and now I hand over to Heather, my colleague. So Heather, please. Is Heather here? All right, so Heather is here, not here, so our agenda looks very interesting. We have 3 presenters. First of all, openEHR meets OMOP, then FHIR meets openEHR, and then finally we have a presenter from Zuyderland, the Netherlands, talking about a practical use case. So the first steps to openness in the Zuyderland context. So the first presenters, Gustav, Bellika and 𝗙𝗶𝗿𝗀, they will talk about openEHR and OMOP, a research partnership. So please, Gustav and 𝗙𝗂𝗁.
Thank you. I think I need the opportunity to share my screen. There you go. Okay. Can you see my screen now? Okay, yeah. So my name is Gustav Bellika. I'm a professor at the Norwegian Center for eHealth Research and the Arctic University of Norway. And I will talk about openEHR meets OMOP, research partnership. And this is the theory part of 2 presentations. I will take the theory and 𝗪𝗪𝗪 will take the practical part. So who am I? My background is in computer science, and I'm a professor in medical informatics. And I was the initial developer of the SNOW system for reuse of clinical data. And SNOW system is named after John Snow, the one called the father of modern epidemiology, is not the one in Game of Thrones. So I work within medicine, medical research, telemedicine, eHealth, disease surveillance, and clinical research informatics since 1992. My teaching have been introductory and advanced courses in telemedicine and eHealth systems.
Gustav, please, could you have the presenter mode?
Presenter mode?
Yes.
Share the screen, I think, because you're saying the slides.
Oh, this one, yeah. Sorry.
Thank you, no problem.
I can switch like that.
Perfect.
Yeah, okay. So in biomedical informatics, this is the fundamental theorem, and it says that a person working in partnership with an information resource is better than that same person unassisted. And the information resource we talk about here is the EHR system. So how could the EHR system makes the clinician better? Okay, so some quotes. A potential for EHR system to support clinician in improving practice. Here's one from 2014. The EHR could be a natural environment for innovative tools that help clinicians identify knowledge gap, address risk gaps, and improve practice. So there's a potential here for the EHR system to support the clinicians. So the EHR as an information resource. And this paper that was published 30 years ago now talks about what we need, what we know about the information needs of physicians while caring for patients. 30 years is a long time. And already at that time, they knew this is one way of categorizing the information need of physicians. I like this very much. And of course, a physician needs patient data about the patient they are seeing. They also need population statistics. They need medical knowledge, of course, logistic information about how to get the job done, and of course, how others get their job done. There are other classification of information need, but I like this one the most. And this was published 30 years ago, but I don't think we're moved very far on some of these areas. So I will go into these areas one by one, except the patient data, of course. So population statistics, I like this quote from Mervyn Greenlick from 1992. The probabilities that a physician faces with an individual patient in a given circumstance are specific to the characteristics of the population from which that patient comes. A physician who does not have data on this specific population does not have all the relevant knowledge necessary to treat the patients. And this can be illustrated by if you take a doctor from northern Norway and send the person to Africa, he wouldn't maybe perform very well in the beginning. And the same if you take a physician from Africa and puts him here, he wouldn't perform very well either, because the populations are different. They have different diseases. For the EHR, the epidemiological data from the local population, we could summarize that from the EHR used, or from a microbiology laboratory in a local community. However, this is still not available in the EHRs of general practitioners in Norway. And if we get a new pandemic, this is needed to handle this disease outbreaks efficiently, I think. When it comes to medical knowledge generation, that comes from clinical practice-based research. And EHR system could support clinical practice-based research and reduce the workload of the physicians that are involved in these clinical studies. For instance, they could find eligible patients matching inclusion criteria, or do longitudinal monitoring of outcomes for the study cohorts, or support comparative research for alternative interventions. However, the reality is that at least in Norway, that this is not present there. So there's room for improvement and support for clinicians. When it comes to logistic information, that is instructions on how to get the job done, and that could also be generated and adapted to each patient case by the EHR. Some examples here. What do the physician need to do to fulfill guidelines? What tests to orders, what examination to perform, what medication to prescribe, what not to prescribe. And if you look at the research literature over these 30 years, there's been a lot of research that exemplify what the questions that clinicians ask. This is one example provided by Eli 26 years ago, and the situation is more or less the same today, I assume. So this paper was from, the latest paper was from 2014. And social influence, that is information on how peers get the job done. That could also easily be provided by summarizing EHR data across the EHR systems that physicians use. It would help the physicians avoid practice outside established practice norms, and would also support Helsinki Declaration Article 5, which states that even well-proven interventions should be evaluated continually through research for their safety, effectiveness, efficiency, accessibility, and quality. So all these examples, what do we need to do to improve support for physicians' information need? Well, the basic thing is that we need to agree on how medical data is stored in the EHR system. We need to enable interoperability. And openEHR provides the mechanisms to produce these agreed upon information models. And what's also very nice is that openEHR provides mechanism to efficiently reuse EHR data. And tools exist that efficiently transform EHR data from to the OMOP data model that is used in a global network for medical research. It's called 𝗿𝗂𝘁𝗺.
Okay.
So now Diego will show you how to do this. And I'll take the opportunity to thank you for your attention.
Yes, 𝗪𝗁, if a question.
No,
Okay.
just to say thank you.
Okay.
Thank you very much. Thanks.
No worries. So now that we have like a background of theory, I want to present to you what we have developed with. First of all, I'm Diego Boscá from Beratec, and we have been working with 𝗪𝗁𝗪 and other partners to develop like an open source tooling to this kind of transformation from openEHR into OMOP. I will try to be as fast as possible, but please bear with me. So as we already know, the OMOP is the de facto standard for real-world data research. And as we already know, if we have worked with OMOP and any kind of like non-standard database, you know that it's kind of difficult to get like OMOP from the inner like databases that exist out there, because you don't have like usually don't have the data dictionaries. They use local terminologies. There is a lot of silos that you have to integrate somehow. And in general, there's little like possibility to reuse CTLs from one site to another, right? And also, if you have different sites that are trying to use OMOP, we have to kind of reach agreements on what we are representing beforehand, because if not, we'll get like different layers of agreement. For example, some conditions are kept and others are not kept in the system. So we can have like difficulty even doing research, right? So why we should use openEHR as source of truth for this transformation? So as Gustav said, openEHR has clear semantics. So we know for each maximal data set what is the meaning of each one of the elements. And again, we also have like rich internal values that are defining what is supported and allowed in each case. In principle, we could see like a single mapping for each archetype. in a way that we can just define the mapping and say, okay, this is how openEHR understands this should be mapped into OMOP. I think that's a clear advantage for openEHR in this regard. And this will mean that this archetype data will always provide the same OMOP data, and that's a kind of an improvement. And again, these mappings are proposed now right now, but they should then, like, once we validate them in the openEHR cie_m, so you will get like the openEHR archetype, you will get like the OMOP mapping, you will get the FHIR mapping. Every mapping should be available in the cie_m too, so it's easy to reuse them. So a quick overlook of the tooling. So we created EOS, that is an open source tooling that is taking like a mapping definition in YAML that I will show you a little bit later on. And it's taking that definition to go into an openEHR repository, do a query on that repository, and then create like OMOP data, like insert in SQL, right? So it's like very, very low level tooling that is just doing what you told him, like, I want this patient's data into OMOP, and they will do that. We will, patient by patient, getting all the mappings that you have defined and you have available, and then get the data into OMOP. So you need less like data, you will get like less mappings, and then say, okay, I am interested in these 4 things, and this. As I said, the format itself is a YAML format. The idea is to get like openEHR paths and put them into the OMOP like attributes, right? So for example, in this case, you will declare what is the OMOP class. You will say what is the concept ID. In this case, it's a fixed concept because we will have like a mapping, a binding in the archetype. You will take the date and how to process the value. In this case, it's a concept map that you will say, okay, the internal code is mapped to this code, and etc. etc. Okay, that's kind of the philosophy. So you have like source and data paths, and you will get like data out of openEHR, right? This is only working for getting that data from openEHR to OMOP, and not on the way around, because that will be much difficult for things we will discuss even later. So this is the general idea. These mappings are already available to review, so I will let you know where it is later. But in general, the idea is, as I said, you will get like for the mapping, the EOS will create like a SQL query, like a archetype query, and then we'll get the data and put that into like an insert of the database. It's really straightforward in general. Of course, you have to care about data type mappings and so on. That will be done automatically, but in the end, it's just about the paths. So currently, we have already mapped 196 archetypes. They are mapped to 296 OMOP entities. As I say, it's already up to date with police archetypes. In the first iteration, we tried to map like a patient summary, but then we realized that it was really interesting to have all the published archetypes mapped to OMOP. So we have already in this repository the proposals of the mappings. So if you're interested, just go there and check them. Again, we have to validate that to put that into cie_m. So the more people try to do that, the better. And now I will tell you some of the lessons we learned about this process. So in theory, you will not need more ad hoc ETLs for getting your data into OMOP. So we get like a single way to exporting data, and that's an open strength, I think, because in the end, this works for OMOP, but it will also work with any kind of other research standard or even FHIR. We have found that the rich internal value sets from the archetypes are sometimes more detailed than the ones that are available in, for example, SNOMED or ROINC, for example. And that's probably because archetypes are really like going in the edge of the knowledge gap, maybe, or the knowledge curve. So we always get the latest good thing, but in the terminology is maybe slower to adopt and slower to get into OMOP. There are some specific problems in some places that we have to actually decide which are the elements of the archetype that are really interesting to be put into the OMOP, because different elements in the archetype could end in the same element in OMOP. I think, for example, conditional status and things like that, that we have, for example, very detailed definition in openEHR, and we only have like a single page in OMOP to put that. But in general, my message for today will be like, be part of this. This is like a open source tooling. The mappings are already open and just need to be validated. So please review them, help us validate the mappings. We can improve EOS in any kind of need you have. For example, if you are needing in supporting an OP extension or some use case we haven't thought about, please let us know. Create an issue in the GitHub and let us know. And I'm getting this opportunity to also announce the cie_HEAS, but we are in the starting phase of creating a 𝗪𝗁𝗁𝗪 working group with this openEHR to OMOP mapping. So please also be involved in that. And yeah, that's all what I wanted to say today. So thank you.
Thank you, Diego, and thank you, Gustav. Very informative. We have actually 1 minute, so one question, if anybody has got a question. Okay, there is no question, so maybe I ask a question. So, Diego, Gustav, what is your advice to leaders, managers who are shaping their data strategies currently? So a very short answer. What is the advice?
For me, it's like do the work in the beforehand. So you have to get the knowledge first, and then when you know what your data looks like, then you can go anywhere you want. But you have to be very precise on what is your data that you are storing, and then you can do whatever you want. You can do communication, you can do research, you can do whatever you want, because you know what is there, and that's probably the more like maybe change that you need to do is like don't think that you have like databases, think that you have knowledge, and that's probably the most important thing. Yeah.
So from foundation to use cases.
Yeah, exactly.
Gustav, do you want to add anything?
Yeah, I can add. To really move on to a learning healthcare system, we need to embrace this tool to reuse clinical data, because it can improve the practice. I believe that is true and possible to do, but we need to agree on the data and to start reusing it for research and all the things that it can be reused for. Right.
Super, thank you. And then we will move forward. So next we have the another partnership. So FHIR meets openEHR this time. So we talk about patient consent in action. And Luis, please take the podium.
Yeah. Give me a second to share my screen, and I will.
I have a quick question, if you don't mind asking, please.
I think we don't have any time now for any further questions. So please, could you put it to chat, and Gustav and Diego will handle that.
No problem.
Do you see my screen?
Not yet.
I can't see.
Not yet. Not yet. Okay.
Nope.
Let me see. Now?
Yes.
Yeah. Okay.
Now, perfect. Go ahead, please.
Okay. So good morning, everyone. My name is 𝗪𝗪𝗪𝗪𝗪𝗪𝗪. I'm a senior technical consultant at a company called 𝗪𝗪𝗪𝗪𝗪, which is based in Germany, particularly in Mannheim. And first of all, I would like to thank openEHR for the opportunity to present our work here regarding patient consent and clinical research at Ruhr-Universitat Bochum, because it is, in my opinion, a very interesting but also challenging case study, since we need to leverage carefully complex topics such as patient consent and different standards such as openEHR, FHIR, and also terminologies. So before I joined Vita Group, I was working also with Gustav at the Norwegian Center for eHealth Research, and I've been also working as a consultant for WHO during several years in the past. And so I will introduce a bit our platform. So I think it's important to understand how it works, to understand the case study. So our flagship is the Vita Group Health Intelligence Platform, which is basically an open platform in the sense of the way Heisenman and colleagues proposed from Harvard Business School. So we don't pose any restriction on the use of the platform when it comes to using the APIs. There's no charge. We allow, based on openEHR principles, to avoid vendor locking, and also we allow different partners to plug their functionality to extend that platform, and you will see how that plays a role in this case study. So nowadays, of course, it's important not only to remain on openEHR, but we also need to actually enable the use of many different standards such as HL7 FHIR and also HL7v2. As I said, it's important to provide open access, so every transaction is to be free of any charge. And not only that, but it's also important that the customer, and particularly when we talk about research, is able to execute data control. So in many cases, and the European legislation speaks about data controllers, but we've seen in the past that in many cases, exercising that control can become challenging. And to that end, you need an openEHR open source code that allows you to explore the code and potentially to actually explore the persistence layer to extract your data. To the very end, build a research digital ecosystem. So the platform is mostly based in German hospitals. So most of our market is in the German region, in the DACH region, and Austria, Germany, and Switzerland. And so we have done research projects and also different interoperability projects with hospital networks, which are private, like Asklepios, but also public ones, and including cie-𝗽𝗲𝗁, Hanover Medical School, and many others. And currently, we provide a regional CDR in Catalonia. And in the past, we've also, through the open source version of Airbase, allowed the 𝗪𝗲 epidemiology platform in Africa. So as I said, it's important to have the platform in place. It has to be multi-standard, but ideally we should be able to actually plug in different components from other vendors and potentially homegrown products. Here you have also a QR for our partner program. And that's what we did mostly at Ruhr-Universitat Bochum. So basically we placed the HIP at the core of each of the hospitals, and we enabled the translation from openEHR into FHIR and HL7 version 2 through a pseudonymization process. So in that way, we enable the use of data, in this case for research, but also potentially for KPIs, information exchange, registries, and continuity of care. So basically, what we act is as a data warehouse of data that can be identifiable or not, depending on the needs. So, and now going in depth into this case study. So Ruhr-Universitat Bochum is a hospital with 15 employees and approximately 5,500 beds. And the challenge was actually to enable for Ruhr-Universitat Bochum enabled research in compliance with the German law, to be able to connect to the German medical informatics initiatives, which act as research networks across many hospitals in Germany at the national level. And to that end, we need to enable also patient consent, and that was done with FHIR. So starting to introduce the architecture, basically, here you see 8 different clinics which compose the RUP organization. So RUP is composed by 8 different clinics which are independent. They operate independently, and also they want to keep control on data in their clinic independently, one from each other. So that means we had to deploy an instance of our HIP CDR in each of them. So they would move that data that was considered of interest for research to the platform, and that was done by ingesting data in HL7v2, which is translated by our CDR bridge into openEHR and stored in the HIP openEHR Airbase Enterprise Core. And some of the data is actually stored also in FHIR if it is more demographic data and so on. But this is done at the local level of each of the clinics, since this is still identifiable data. Now, before serving that data to the national level, to the medical informatics initiatives, we had to enable a pseudonymized version of that data. And also, we need patient consent. So we need to control if the patient has or has not consented for the use of that data. So for those that have consented, actually, we go through an pseudonymization process. And in that process, there's a trusted third party, which is a different entity from RUB. So it's a different legal organization. And this is in compliance with the German law that provides the pseudonyms. So it is only that third-party organization, the trusted third party, that is able to potentially link eventually the pseudonyms to the real IDs of the patients. So once data has been pseudonymized at this level, this is a central data warehouse for the 8 clinics containing pseudonymized data. It becomes ready to actually be served on demand to the different medical informatics initiatives in Germany, like 𝗪𝗲, the Codex platform, or 𝗪𝗲𝗪. I'm going to explain now in depth this complex process, and then we can, if we have time, we can answer some questions about it. So how does this work? Because it's a challenging workflow. So basically the patient, when they go in Germany to the doctor, signs a patient consent about the use of their data for research. And that is done in paper, okay? So this is a paper document which is delivered to the clinician and it's signed by the patient. Now, we need a digital version of that. So what happens is that eventually those consents are provided to a clinical worker, a clinical documentalist, who scans them and stores them in the 𝗪𝗁𝗏. So they basically stored the scanned copy of the original document, and that clinical worker, that documentalist, also types or selects the different modules that the patient has authorized for the data to be used for. So in essence, in Germany, this patient consent is divided in different modules for prospective data, retrospective data, insurance data, biosampling, and so on and so forth. And the patient can select yes or no for each of them. So this clinical worker basically selects which of these modules have been activated for the patient. And that is stored in a FHIR consent store, okay? In parallel, data has been exported for all the patients, consented or not, and this happens at the local level. So this is for each of these clinics in an identified way. So there's a subset of data considered important for research that has been exported into each of the openEHR data stores of the 𝗪𝗏 platform. And so this is one tenant per organization, so everything is encapsulated and still within the organizational borders or firewalls, okay? So when a patient has consented, we are allowed to actually pseudonymize that data and share it for research. So how does this work? Basically, we have a data export component which monitors what consents are available in the system. So when a new consent has been detected, this is a process that typically happens every 24 hours. When this new consent is available, then the ID, the list of IDs, is shared with a trusted third party, which is, as I said, it's a different legal entity from the RUB clinic. So basically all these IDs are sent to this trusted third party, and the third party provides a list of interim pseudonyms. And I say interim because you will see later this is not the final pseudonym, okay? But with these pseudonyms, basically we can create with our CDR bridge the FHIR version of this openEHR data. So this is translated into FHIR, and the pseudonyms are assigned. So data becomes pseudonymized. And that data is sent to this central data warehouse for the 8 RUB clinics I was talking about before. So this is a central research platform. I will go back and show you. So we are now at this level. We are sending pseudonymized data, okay? But before it gets persisted, we need to go and understand what this data import component does. So as I said, these are interim pseudonyms, and there's a legal reason for that, in compliance with the German laws. So the data import component needs to actually do a second pseudonymization of this. So it will send each of the interim pseudonyms in the FHIR consent in the FHIR data to the trusted third party, and that trusted third party will issue a final pseudonym. And that is the pseudonym that finally will be stored in the central research platform. And that is the data that, upon consented, when it is consented, actually is served upon request to the different medical informatics initiatives that exist in Germany at the national level. So why this two-level pseudonymization? This is because if we don't do this second-level pseudonymization, there's a potential that the export component could re-identify the patients that are in the central research platform, since they have both the IDs and the interim pseudonym. So with this second pseudonymization process, we make sure that it is only actually the trusted third party that potentially can do the linkage between the pseudonym and the real ID of the patient. And I'm going to show you now, this is the graphical user interface, it's a video. And this is basically the graphical user interface that the clinical health worker or documentalist uses when they receive the paper-based version and they need to digitalize it, okay, and put it in a FHIR compliant way. So basically, they can, through our patient viewer, they can search for the patient name. And then they can explore all the data. So the name, the last name. So these are demographics that actually come also from our FHIR server within the HIP. The patient contact data, the address. Other contacts that may be available. So they can also see more inpatient stay data about the admission, discharge, the ward room if available. And potentially they can also visualize health data. So here they can basically explore the timeline of the patient and the different openEHR compositions that have been stored here. So in this case, it's a medication request. And for that patient, then they can go to the consent space. They can, in this, let me stop it here. So in this document section, is where they can upload the digitalization of the document, in the sense of the scanned copy of the paper document. So everything is clear and according to what the patient actually signed. And then they can go to the consent space. And here is where they can trigger the creation of pseudonyms, and also define a new consent. So in this case, what we are defining here is a new consent for this patient based on what we had in the paper form. And this is going to be the MII-160, which is the consent for the Medical Informatics Initiative research. They have to report who collected that consent, what clinician, the date of signature of the clinician, and the date of signature of the patient, and the validity that has been established for this consent. So when the validity starts and when it finishes. So in this case, it will be valid until the March 2030. So here are the modules I was talking about. So here what you see is actually, so this is backed up by a FHIR consent resource. And here what you see is all the modules, and they can check for each module, for example, prospective, the use of prospective patient data, the use of prospective health insurance data, retrospective health insurance data, prospective use of biosamples, In this case, we have selected no in this example, collection of additional amount of biosamples, renew contact for scientific questions, and renew contact for additional findings. And then they can save the consent. So as you see, what you get is a summary of all the modules where the patient has consented in green, and those not consented, like biosampling, in this case, with no, and the metadata with the status active collected by this doctor, the validity, and when it was created. So this is for the creation of the consent, but even more important when it comes to compliance with GDPR and the German regulations is actually to allow the patients to exercise their control on their consent. So potentially this has to be editable. So in this case, we can check the history, and if we want to edit the consent because the patient has contacted the clinic, or in a second visit they want to do an edition of the clinic, we can potentially edit this consent, and everything is, of course, audit all the actions. So in this case, the patient does not wish anymore to receive any contact for scientific questions or additional findings, and we can save that. And there's another case where not only editing, but potentially the patient may want to actually withdraw consent. So his or her data is not used anymore for research. So in that case, they can withdraw. And the clinician, the clinical worker can select a reason for this. And once the patient withdraws, the data will no more be used for research. So they can select a reason. Patient has objected to the consent, and they can withdraw their consent, thus exercising then their patient rights, withdrawing this use. Yeah. And yeah, so with this, I've finished my presentation. I don't know if we have time for questions or not.
I think, thank you, Louise, a very practical use case, but I think we don't have any time for questions, but there are many questions in the chat, so please handle them. And I would like to give the podium to Marc from Zuyderland. So Marc, please tell about your first steps to OpenEHR.
Let me share my screen first. Is my screen visible?
Yes. Go ahead, please.
Yeah, so let me briefly give you a glimpse into the intended data platform that we're building up at Zuyderland. And we also have a position for openEHR and FHIR here. And so I'm going to very quickly go through this. I'll start off by briefly describing the challenges we're facing, then go through the concept of the platform. Then I'll go into a bit about the framework, the phases, and what competencies are needed to apply this. Whereafter I'll explain a few of the standards we apply and the technologies we're using, and then I'll look into the future. So quickly going through the challenges, Zuyderland is a merger of two hospitals and a lot of outlocations. It's a top clinical training institute, so we also train physicians and specialists. We treat about 500,000 citizens actively. There's 11,000 staff members working at the hospital over 40 different locations, because it's not only the hospital, but there's also care centers, rehabilitation, mental health care, home care, geriatric care, and so on. So it's quite a broad range of care that Zuyderland provides. And within Zuyderland, there are some technology challenges. The well-known data silos in healthcare exist here as well. The infrastructure has its limitations. It isn't that easy to exchange data between systems, also with the outlocations. And there's also a lot of consequences due to the segregation of the organization itself, because although a lot of these different components are within one broader organization, they are still by law separate sub-organizations. And then there's the regional challenges. Zuyderland is within a region that is ahead of the national curve in the Netherlands. We have a faster aging population, higher disease rates, there's lower education, there's a high prevalence of unhealthy behaviors compared to other regions. There's a growing gap between demand and supply due to the aging healthcare group as well. The providers are aging as well. And there's also a lot of collaboration and information barriers within the region, making it difficult to actually use a well-founded IT infrastructure to share information. Aside from that, there is also the broader aspects, such as the regulatory changes that are happening, NIS2, AI Act, that kind of stuff. There's this huge explosion of AI systems that are approachable, affordable, easy to integrate due to the way they are SaaS systems. There's the healthcare IT modernization that's highly necessary. There's more and more data-driven solutions coming to the market. We need to be able to support them somehow. And as I mentioned, the regional pace is ahead of the national pace, so also Zuyderland's strategy is ahead of the national pace. So all in all, there's external driving factors that require the hospital to support a more modern ecosystem. There's market movements, there's the request for more data ownership and decentralization of data. There's the internal organization shift. Everything boils down to this huge need for a paradigm shift within the hospital ecosystem. And that's where the platform concept comes up. So if we take a look at how the IT ecosystem is set up, then we start off with a system which has some data storage and messages in it. And in itself, these systems aren't quite useful. So we add a secondary system, and then there's communication between these systems. So we're now slowly moving towards an ecosystem as we know them within hospitals. We also extract some data for our in-house solutions because we need that as well. And this ends up, if we explode this into the classical data landscape. A lot of people have known this landscape in the past. It's very complex. There's a very low level of control you have over this landscape, especially regarding data. A lot of point-to-point interfacing and focus, so it's also difficult to get your data together. And as a solution to this, the message brokers were introduced. Where messages are basically handled through a centralized point. This is also where standards start to really get a grip within the messaging ecosystem. And we also introduced this warehousing concept, and this is the broker data landscape as we know it now. There's messaging, so there's far less point-to-point communications, but still some systems need to communicate direct over the data layer, not through messaging. There's this warehousing where we have this huge centralized solution for all of the in-house solutions. And there's a lot of funneling happening here, which is good because it increases your control. Performance issues are something you have to focus on more, but it works really well. And so at Zuyderland, we asked the question, what if we take this brokering and make a data broker instead of only messaging? It basically integrates all of the key data, all of the information objects that you deem essential into a data platform. To do this, you have to maximize the types of interfaces you have. And also, it explicitly separates the source and service flow. So a data source must always pass its information through the data platform to reach a data service. This way, you actually can apply the broker. So if we would want to do this with clinical data, then the landscape would end up looking something like this. There's this integrated data platform, which both handles messaging, tightly coupled to messaging at least, and it has this huge monolithic storage of all of the relevant clinical data. It's very tightly coupled to the broker so that if messages pass through the broker, they can also be put into this clinical system. But it's loosely coupled to the different systems around it. So if we take a look at the story, then we see that the classic data landscape brings a lot of challenges because the levels of isolation are difficult to handle, all of this point-to-point communication. The brokered landscape brought a lot of improvements, but it missed the mark with stored data. And the open data landscape is the evolution of this existing approach that we have by also starting to broker data itself. But we also win the benefits of an open data ecosystem in this way because the organization itself can choose which data is available to which systems. At Zuyderland, this works out like this as a conceptual design. There's this core platform. It's a layered model that we chose to set up. You can see that we separate the sources and services here, that we have an explicit layer for interfaces so that we have multiple options to connect with the operational data. And there's a hybrid transactional analytical processing methodology so that analytical queries can be run directly on the operational layer, which is exactly what you would want, because at the moment that research data is requested, you want to pull this at that moment from the operational layer and not some historical data set, so that we have the most relevant data available at the time of request. But still a separate analytical layer because we do need to actually store the snapshot for future reference. So how does this work in a bit more closer to practice? Well, we have quite a big framework set up for this by now, and we've been implementing this for the past 2 years. We introduced 6 points of control so that stakeholders can actually follow the progress of the work they've requested. There is a differentiation between what we call workloads and layers. The workloads are the approach to getting source data into the ecosystem, and the layers is the work done to get the source data available for business use or research use. The data capabilities describe the different types of teams or specialisms you need to be able to do this. This also gives the organization a steering point on which capabilities they find more important. Do we want to ingest more data, or do we want to increase the speed of releasing data and making it available? And data management is placed at the core because basically any data that lands within the ecosystem needs to be well managed to ensure that the use of data is also well steered. If we don't apply mature data management techniques, then we notice that the adoption of this ecosystem actually quickly deteriorates. If we take a look at these phases, that we work with, there's in total 6 of them, but the most important 3 are this bronze, silver, and golden workload, in which we ingest data, apply quality control, and then put it in a sustainable storage. In the case of clinical data, this sustainable storage is an openEHR ecosystem. And for analytical layers, we use a data federation in which different groups can request access to data and then start using it in a format that they need. The data landing zone is the part of the bronze layer in which we also, for example, transform data into OMOP. And that's how this design was set up, so that anyone requesting data would not have to know and learn the openEHR layer, but can use their existing OMOP queries. The capabilities that we describe to be able to do this are 3. There's an operational, integration, and analytical capability. And the operational capability focuses purely on onboarding data. So this involves data engineers and modelers. There's quality experts as well, but they're advisory. They actually hand over assignments to the engineers and modelers to ensure that they can fit the quality improvements. Then there's the integrations capability, which is more of our operational side of this platform, where we integrate various systems using this. This is for online systems and not research ecosystems mostly. And the analytical capabilities is where research and secondary use comes in. in which we aim to have predefined data sets which can be used within the data mesh instead of having to wait until your data is prepared for you. Your request checks if it's available, and then you can start utilizing it if you have the permissions. So what standards and technologies do we use? We extended on existing stacks and ended up with what we internally call the Foxtrot stack. So in the sustainable storage layer, we aim for openEHR as the storage and DICOM for medical imaging. And then on top of that, we have FHIR for integrations and of course AQL, openEHR queries for items that aren't covered well enough by FHIR. An example of that is OMOP. So using AQL, we can transform data to OMOP, and then we can make an OMOP viewer available where researchers can request OMOP data sets, see what they're like, and then have a snapshot stored. DICOM is also made available for research if medical imaging is used within research. We aim for SNOMED CT because that's what the Dutch national ecosystem is mainly aiming for. We also are slowly integrating SMART into this ecosystem for granular access, but that's for operational systems mostly. And OMOP has been definitely chosen as the research data set that we're working with. If we take a look at the technologies, we use reusable solutions mostly. Wherever we can, we apply that so that smaller hospitals can, at some point, reuse the stack that we've implemented. Python modules and notebooks so that we can, at some point, open source the code we have. We also prefer cross-sector technology so that we can find specialists in other sectors due to the small pool within our ecosystem. And we try to balance standards with flexibility because although it's very important that we start adopting the standards, there's also the actual operational side of what we're doing. So we don't always have the time to adopt the standard to model it within the time frame of projects. So where is this going from here? Well, we're slowly inviting collaborations with different vendors and partners because we want to really build this up in a way that other hospitals, other healthcare organizations in the Netherlands can easily re-adopt this. We're looking into miniaturizing this platform as well. There's quite a few vendors we've been working with where the challenge is that their customers don't have this platform, but they do want to standardize towards these standards and have a way of adopting it. And because this does the ingestion of data, the onboarding so well, they would like to have some miniaturized version that they could include in their propositions, which would be good because that's an easy way for others to adopt this if they have a vendor that can partner with them. We also are looking for these more collective shared benefits. For example, if other hospitals or vendors start modeling stuff for us, that helps a lot. There's actually a hospital who is specifically working on modeling the the mostly used EPD system in the Netherlands. So that's the direction we're focusing on now, next to the ongoing development of the platform. We're also broadening the scope of the platform as time moves on. So we're looking for a more universal access approach. We want to scale this so that it's more broadly used. The more we can scale this, the more systems we can onboard onto it without disrupting the use of data. But also if this scales in the right manner, for example, if we can federate this nicely, then within the region, it also becomes a core platform, which is more interesting for the university hospitals that we collaborate with, because this unlocks a huge data set that they could potentially use to investigate the region instead of only single hospitals. The shared solution approach is getting a lot of interest because we do notice that other parties are asking for what we've developed, but they also want to bring in developments from their side. And the national initiatives is what we're focusing on as time moves on, because we want to connect to whatever the Netherlands nationally decides. We also actively try and communicate what we're developing with those groups so that we can steer things a bit more in the direction that we believe is sustainable. And then we end up at this last part where we're trying to make this also enterprise viable. So maintenance and support is quite a big challenge there, because there's a lot of new components that we're using here. That's why we're also in discussion with various vendors to explore what the best solution would be there. And there's a lot more on the roadmap. There's AI integrations to ease the ingestion of data. There's decision support systems that we want to be able to support by integrating more standards such as GDL2. We want to increase the sovereignty so that it can be packaged and moved to your own hosting instead of per se using cloud hosting. There's implementation details, zero trust and security roles and responsibilities. A lot more that we need to go into before we're done with this. So all in all, here at Zuyderland, we noticed that there's this very forward-thinking approach. The platform aims to modernize the ecosystem. There's also a very huge focus on interoperability. And the governance and collaboration with the hospital is increasing more and more as time goes on, which improves the quality of the data. And that's it for me.
Thank you, Marc. Zuyderland is one of my favorites, I have to admit. And it was so lovely to see the target architecture, and I think it's lovely to end this webinar with your target architecture, all these open standards working together. So lovely. There's also one question to you, Marc, from Christoph in the chat, so please handle that later on. Thank you all presenters, super work, and also thank you for attending our webinar, and the recording will be available to everybody as well. Can you please take a moment also to look at David's evaluation form, because it would be really good if you could take a minute or two to evaluate our webinar so that we will be even more successful next year when we are going to have the next webinar. So thank you, and have a nice day.
Bye.
Cheers.
Bye. Thank you.
Thank you.
I think you should start. I think you're fine to start now.
Okay.
I think you're fine to start now.